Hi everybody, this video is on double displacement or replacement reactions. And the general form of this type of reaction looks like this. So we would have compound AB plus compound CD, and that would give me compound AD plus compound CB. So this is the one where we have two dancing partners and they switch partners. And you can always recognize a double displacement reaction because we have two compounds reacting. So let's try one. Let's say you have calcium sulfide reacting with sodium hydroxide. So here we have two compounds. So we know it's going to be double displacement. So what you have to do is figure out what the ions are, and then we're going to figure out which ions switch. And remember, opposite ions attract. So calcium ion will be attracted to the hydroxide ion because they're oppositely charged. And the sodium ion will be attracted to the sulfide ion. So let's do the sodium ion first. So how do we put it together? So we have sodium's +1 and sulfur's -2. So we're going to need two sodium ions to balance out the sulfur ion's charge. So we will get a compound Na2S. So what are we left now? We're left with calcium ion and hydroxide ion. The charges don't balance out. We need two hydroxide ions to balance out the charges. So if we do that, we'll get calcium hydroxide. Looks like that. Now it's not balanced yet, so we're going to do that. We have two sodiums on the left, so let's put a 2 sodium there. And now we have two hydroxides on the right, and that works out here because we have a 2 in front here. So that means we have two hydroxides. We have one calcium, one sulfur, one sulfur. So that's balanced. Let's try another one. Let's do aluminum chloride plus copper nitrate. So we know this is a double displacement or a double replacement reaction because we have two compounds. So we have to predict the products. To do that, we need the charges on the ions. Nitrate is a polyatomic ion. You'll find it on your polyatomic ion table and it has a charge of -1. When you look up copper, it comes in two flavors. That means it's multivalent. Which copper is it, +2 or +1? Well, it's attached to one nitrate, which has a -1 charge, so the copper must be the +1 variety. So now we have to figure out who's going to dance with who, or which partners are going to change. And remember that opposite ions attract. So the aluminum then must hook up with the nitrate because they're oppositely charged, and the copper is going to hook up with the chloride ion. Okay, so how does that happen? So aluminum is +3, nitrate is -1. So we need to get the charges to balance out. So I'm going to need 3 nitrates because that will be -1 plus -1 plus -1. That will be a total of -3, which will balance out the +3s. So that compound will be aluminum nitrate, and there's 3 of them, which leaves copper +1 and chloride left to do the chemical tango, and we just need one of each to get it to balance out. Now it's not quite balanced yet, the total chemical reaction. I've got 3 nitrates here, so I'm going to put a 3 there. So that means I have 3 coppers on the left, so I'm going to put 3 there for 3 coppers on the right. So that means I have 3 chlorides there, and look at that, I've got 3 chlorides, and 1 aluminum here and 1 aluminum there. So that's balanced. There's another type of subsection for double displacement, and we'll call it acid-base reaction. And be careful the government doesn't trick you on this one. An acid-base reaction is like a double displacement reaction, except it involves, you guessed it, an acid and a base. And remember, acids start with hydrogen and bases end with hydroxide. So just keep that in mind. Okay, so we have an acid and a base. So the same thing's going to happen. Same process as we used for the double displacement. We got to figure out the charges on the ions, like that. we have to figure out which ones are going to switch partners. So remember, the positive ion is going to be attracted to the negative ion, like that one. And here, sodium ion is going to be attracted to the chloride ion. So let's put that together. So let's do the sodium and the chlorine together. So we just need one of each to balance out the charges, and then we're left with H plus and OH minus. And when we put those together, we get HOH, also known as H2O. Whenever we have an acid and a base reacting together, we always get a salt plus water. So keep a lookout for those acid-base reactions.